Alright, welcome back to part 2 of Unit 6, Section 6.1, Solving Equations using Inverse Operations. So our learning goal is just to reiterate from part 1. So I'm going to model and solve linear equations. That's the I will statement. I can model a linear equation. I can verify my solution by checking with substitution. I can solve symbolically for a problem. I can solve pictorially for a problem. And then I can record my steps to show my work. So we left off halfway through our sheet, so let's begin. Okay, so we have question 5. 2x minus 6 equals 2. So we're going to start off with x. What happens to x? Well, x is multiplied by 2. And that gives us 2x. And well, then we are going to subtract 6 here. And that gives us 2x minus 6. So there we've built our linear equation there. And on our right hand side we have 2. And then we're going to do the inverse operation. So instead of subtract 6, we're going to add 6. Well, 2 plus 6 is going to be 8. 8. Instead of times 2, we're going to multiply by 2. The inverse operation that would be divide by 2. 8 divided by 2 is 4. So let's work at that algebraic solution. So my algebraic solution would be 2x minus, or subtract 6 equals 2. Let's see if I can solve this out here. So first thing, we have to add 6 to each side. That's going to leave me with 2x equals 8. And then x is being multiplied by 2, so I need to divide both sides by 2. Therefore, x will equal 4. Let's just do a little check. So let's check and see if that's right. So 2, and instead of writing x, we're going to write the value of 4. 2 times 4 minus 6 should equal 2. Well, 2 times 4 is 8. 8 minus 6 is 2. And that equals 2. Therefore, we have solved it algebraically, recording and showing all of our steps. Perfect. So this is algebraically, pictorially, same thing we've solved over there. And still, even if you did this pictorially, you should substitute just to check. So we've checked here algebraically so that our left-hand side does equal our right-hand side. And then sometimes in some textbooks you'll have LHS, left-hand side, equals RHS, right-hand side. It's just a little bit more advanced, but still. Now we have question 5. So x is being divided by 5. Okay, x over 5 means x divided by 5, and that gives you x over 5. And now we have x, and we have plus 3, so that means we're going to add 3 here. So x over 5 plus 3 equals, well, in this case it's 10. So instead of instead of adding by 3, I'm going to subtract both sides by 3. 10 subtract 3 is going to be 7. Instead of divide by 5, we're going to do the inverse operation. So that's multiply by 5. 7 times 5 is 35. And let's clean that up a little bit there. So 35. And now I can solve this symbolically. So symbolically or algebraically here, we have x divided by 5 plus 3 equals 10. First step is I'm going to subtract 3 on each side. And that takes care of this. So on the left-hand side, I'm left with x over 5 equals 7. 10, take away 3 is 7. And now I'm going to multiply by 5 because x is being divided by 5, so the inverse operation. And we'll cross those out. I'm going to be left with x equals 35. And we could check the same way over here as we went through. It's always good to get into that habit. Just in the case of this video, we're going to move on, but I'd like you to check in your notes. Okay, so we're going to write equations, talking about writing equations here. This is one of the last parts of our first parts of our ICANN, so that we can model a linear equation. So we'll start talking about that now. So to write an equation, we must first write a let statement to identify what our variable is. So it says 7 times a number is 8.4. Okay, so we're going to say let n equal a number. Okay, so we're going to let n equal a number. Okay, so 7 times a number is 8.4. There we go. So let's write out another equation here. So we have a number divided by -5, or divided by -4 is 3. So a number, so let n equal a number. And so like we said, a number divided by -4. So n divided by -4. We say n over -4 equals 3. Some other ways I've seen it written would be n divided by -4. Remember, you have to have this in brackets because you'd have an operator by an operator. Cannot do that. So n divided by -4 equals 3. So either way, both correct. So now what we're going to do is we're going to solve each equation and then check to make sure we're right. That's what we mean by verify the solutions. We have to check our work. This plays into our bit from last chapter where we used polynomials with a term called distributive property. That means when you multiply this 2, it's applied to the m and to the 4. Okay, so let's just multiply this out. We'd have 2m plus 8. And that would equal our 11. And now we can go ahead and solve this. So keep in mind, I'm doing like reverse BEDMAS here. So I would take care of this positive 8. So I would say subtract 8 from each side. So that means my 8s are taken care of. I'm going to be left with 2m. 11 subtract 8 is 3. And 2m, I want to have m by itself. 2 was multiplying the m, so I divided each side by 2. So m equaled 3 over 2, or we could say 1.5. Now, let's verify this solution. So let's check our work. So let's write in our check here. So let's just check this. So if we have 2 times 1.5 plus 4, will that equal 11? Well, 1.5 plus 4 is 5.5 if I do my brackets. So 2 times 5.5 is 11. Whoa, that's a crooked 11. So we have 11, and that equals 11. So therefore, I have verified my solution by substitution. So I put in, or substituted in, 3 over 2, or 1.5, into the original equation, and then I verified it. So let's do the same with the other one. If you want to take a second and pause this video to try it yourself, go right ahead. So we use distributive property, so negative 2 times negative 3, that is going to be positive 6. Negative 2 times negative y, that's going to be plus 2y. Plus 2y equals 7.6. So if we notice here, our orders are a little bit different, but that's fine. I can subtract my 6. Subtract 6. Leaves me with 2y equals 1.6. And divide both sides by 2. So that y will equal 0.8. Okay, let's just make sure we can solve this out by checking. Okay, so same thing, we'll write our check. So we have negative 2. And we always want to rewrite our original equation whenever we're doing our checks here. So if we do this outright, so 3, take away, so negative 3, subtract 0.8, so that is going to be negative 2 multiplied by negative 3.8. Oops. So if we think about 2 times 3.8, so 2 times 3 is 6, 2 times 0.8 is 1.6, as we know from over here. So that would be 7.6. Is it positive? Well, negative times negative is a positive, so yes, this is going to verify itself here as well. And I've checked my work. Perfect. Okay, it checks out. I'll be leaving those check marks all day if you're getting those. So in class, this is what we're doing is practice. So we can begin that as soon as we get to class there tomorrow. Thank you.